Hello 108 students, Mr. McCue here. Welcome back to section 10.3. We are going to focus on graphing on this page. Working our way through the section, we're on page 5, and we want to graph the log functions here, and our first case we're going to work with is when the base is greater than 1. Okay, so we're going to take an example. We're going to say f of x because we've proven these are functions from before. They pass both the vertical line test first and the horizontal line test, so we do have functions. And we're going to say log base 2, again we're greater than 1, result x. Now when you see f of x, we're going to go ahead and put that y there first. And then what I like to do is, this is just a personal preference for me, I like to swap the left side and the right side of the equation and put the y over on the right hand side and say the log base 2 result x over on the left hand side. And the main reason I like to do that is I've trained my mind to go ahead and convert from logs to exponents under this format. Don't have to do it, but for me it makes it just a tad easier. So what do I got? The result x drops down equals base 2 raised to the y. So that's the equation we're going to work with, and I have it sitting over here to the right, excuse me, to the left. Okay, so there's our equation. We would like to graph that. While we are starting up with this, you need to convert these into exponential format so you can actually find values of input and output. Now what's going to be interesting here is I say pick y values first, and it's easier. Now this is a little bit untraditional. You were always x is the input and y is the output. Now while that ordered pair structure must be followed, when you look at this, you were going to pick let x be your input. Now on your hand notes, I've got that written on added. This is going to be input, this is going to be your process, and x is going to be your output. But you're doing that because look where the y is. It's in the exponent, 2 raised to the y. It's a lot easier to pick a value and simply process it or calculate it and put that as the x. Now the tricky part, and that's what this star is all about, is while we said the input was y and the output was x, the ordered pair structure must always be x comma y. That never changes from our graphing scheme. Okay, so now that you got that key point, and I strongly recommend you remember this, easier to start with the y being the input because we're going to put -2 in. 2 raised to the -2 is equivalent to 1 divided by 2 squared, which is 1/4. Now watch the math on when you do those, and watch where you put this. The x goes first. There's the 1/4. The y is the -2, gets put over here. Okay, just like before we talked about the elbow point on there, I'd like to recommend that maybe you go for that first. When you're graphing, you only need to get 3 points to get the trend of the graph. It's nice to do a couple more here to study them, but in my math lab you're going to go ahead and do multiple choice selections, and I'd like you to practice doing a couple expanded y-x tables. Maybe I'll call them that now. So you ask yourself, 2 raised to the what would give you a result of 1, and fairly easy, straightforward. 2 raised to the 0, anything raised to the 0 power is 1, and so I find 1 comma 0, and that is my first point I would graph. That's the elbow point. Okay, we got that. We already had picked 1/4 comma -2. There's 1/4, -2 is about right here. And now we're starting to see a pattern. We're real close to the y-axis, and that's a good time to talk about. That is going to be the asymptote line. That is where the graph will never touch. That is the y-axis. When you graph these, you'll see these with dashed lines going through, so that no matter what value, how close you pick an x equal to 0, the result is never going to come down here and hit the x-axis. And don't forget, the x-axis can be written as the vertical line x equals 0, just FYI. Don't forget, if you remember how we used to graph these back in chapter 3, x equals 0, you go on the x-axis, you find where you're at, and you draw a line through that dot perpendicular to the axis you're on, thus you would generate the y-axis here like I showed. Okay, so keep in mind that term asymptote. That's where the graph will never touch. Okay, got to pick another value. I think I picked on y being an input of 2. 2 squared is 4. Don't forget to switch it. X comma y, so you get 4 comma 2. 4 over 4 up to. Now we got a couple graphs, and you go ahead and swing through. And I'm kind of trying to mirror it here, but there you go, and you kind of get the idea. Okay, so that's your first graph here we're working on for example 3. Going to move on to example 4. They're now going to handle the case of the base being between 0 and 1. Think of a fraction. So we will pick f of x equals log of 1/2. There's your base, and the result is x. Replace f of x with y equals what we had before. Again, I like to swap the left side right side, so I'm really like to look at log 1/2 as the base, result x equals y, and this is just because I'm training my mind, like I said before. You don't graph these with the word log in, you need to write them in exponential format. Therefore I drop the result. I say x equals the base, which is 1/2, raised to the exponent y. Okay, now we have that. We've got the same situation here where you want your y to be your input. This will be your process. There's your calculation. And the output will be x this time, just like before up here. Now, don't forget, I say be careful. You got to remember that whenever you start this, you put -2 in for y. 1/2 raised to the -2 equals 4. That is your x. So it's 4 comma the y was -2. I just provide these extra cautions because we're used to doing input process output with the x variable first. So you've got to be careful you're switching them to get the right ordered pairs. Okay, so we follow these paths here. I got 4 comma -2. You might want to come over and put that point there to get started. Really recommend, you might want to figure out, if I had the exponent y was a 0, anything raised to the 0 power is 1. 1 comma 0. Remember, x is 1, y was 0, and again you have found the elbow point or the turning point. Okay, so you don't have to go crazy with the values of x. Again, you want to find that elbow point. You want to find where, when the exponent is 0, result is 1. Turn around here and pick up +2 for the y. 1/2 squared equals 1/4. Ordered pair is 1/4 comma 2. 1/4 comma 2. Now you're at 1/4 and you're coming up to here approximately. And guess what? The y-axis is your asymptote like I did before. And you could draw that dashed vertical line and realize this time the graph is starting up high, going to drop down. That's a decay. On this graph here we got some growth going. And we have finished the graphing here for when the base is a fraction. Okay, we're going to wrap this up. Page 5, we got one more to do for section 10.3, so I'll catch you on page 6.